Okay, well, welcome to the May 13th, 2025 session of TAPR-HamSCI technical session. My name is Dave, KB0S, and this week I've been getting ready to go to Dayton. So, got one more day here in Columbia, and then we head down I-70. So, that's about where I am. I've been packing and a few things like that and doing chores around the house. Anyway, next on the list we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. I'm also getting ready to go to Dayton. So one more day in Scranton. I'm going to try to answer all of my emails tomorrow. It won't happen, but I'll try anyway. And then heading down to Dayton with two students and Majid on Wednesday. And today was also nice because I got to give a talk to the Radio Society of Great Britain. They have a webinar series called Mondays at 8. And so I was the main speaker, and then Gwyn came on with me. So we had a nice time giving a talk to them. So
good.
I think that went well, and I think it was well received, and I'm looking forward to Dayton.
Yes, I've watched many of those. They're very good. And next on the list is Elmer. Go ahead, Elmer.
Let's see. I guess my big project for this week, although it wasn't the only thing I did, when I was at Nathaniel's facility, I was troubleshooting noise, and I just didn't understand why I was not finding things. It turns out my tiny SA had cooked a couple of ICs, so I ordered spare parts, and I was able to replace the surface mount and got that back to 100%. And I've been working on VLF integration with all of the other things that we're putting together to get them to be cohabitate together without interfering with each other. And that's probably the big stuff for this group. Next.
Okay. Well, next on the list is Michael, AC0G. Go ahead, Michael.
Hey, everybody. I haven't been terribly active the past several days for competition with other stuff. I will not be at Dayton because instead I'll be in Cleveland at my son's graduation from college from Case Western. So,
yay!
Yes,
Congratulations.
one fledgling. So who's not leaving the nest? He's coming back to the nest. So that's one of the things I have to do is load up the pickup truck with all of his junk and bring it back home. So anyway,
very good.
Back to that.
Next on the list is David McGaw. Go ahead.
Good evening. Basically doing the same as everyone else, packing up to head out to Dayton. Probably get off tomorrow evening, get part way, and then most of the travel will be on Wednesday. And then getting into both the TAPR and the HamSCI routines. And all of that stuff. And go and see what things I didn't know I needed yet.
Yes.
So back to net.
Yes. And let's see. Next on the list is Scott Newell. Go ahead.
Hey, no progress to report this week. I did see, though, that the web SDR guy that Clint knows has a couple of recent write-ups on the 5351 chip. I'll put those links in the chat if anyone is interested, and that's all for me.
Very good. Let's see. Next on the list is Dave Julian, WB9YIG.
Hey guys, good evening. Not much going on here, just kind of making my plan of attack for Dayton. I'll be there as well, so hopefully I'll see you guys there. That's all.
Stop by the TAPR booth and the HamSCI booth.
I will.
We're right next to each other. And let's see. Next on the list is Tom McDermott. Go ahead, Tom. He's used to being last.
Yeah, I'm not used to being up here at the front. I'm trying to copy links and see what Scott said. In schematic capture, Dave and I talked a little bit about it. I didn't get very far before I had to start creating components and footprints and stuff. So I learned how to do that today. Got first two parts where I couldn't find any library parts done. And so trying to learn KiCad from the bottom up or the inside out or something. And that's about it. Back to the group.
Okay, very good. Next on the list is Bill Engelkey. Go ahead, Bill.
Thanks, Dave. Kind of a mixed up week. A friend of mine died on Monday, and we had some issues regarding to that, and a funeral on Friday. And then immediately from there went to my niece's wedding, which was in Greenville, South Carolina. One of those circle of life kind of day and things, you know. Been working with some of the guys on security issues, trying to figure out some ways how to make the system more secure with, I don't know, things like passwordless access and trying to reduce people's privileges to just what they need. It's a little bit more open than we want it to be now. Took a look at some issues regarding some duplicated data in the HARC data. That is the data that we're converting into Madrigal, and it seems that we were concerned that maybe PSK data that's coming from PSK Reporter contains some duplication with some Whisper data, but then I found duplication within the Whisper data itself. There are some cases where the same spot gets reported twice in the same minute, and so there's a lot to figure out on that, I guess. But the Whisper data is a relatively small part of the total data. PSK data is so voluminous, it makes up 95% of the data we have anyway. So some duplication will kind of be washed out into the noise. I'm looking forward to seeing everybody at Dayton. So back to Ned.
Okay, well, I look forward to seeing you. And next on the list is Dave H. W6OQ. Go ahead.
Yeah. Hi. So this week I got the Grape 2 hard drive changed out and shipped back. I guess I was a little behind on that, and also getting ready to go to Dayton. Also signed up for the TAPR-HamSCI dinner on Friday. So I guess I'll see you guys there, as well as at the booth and stuff.
Yes. And our, I don't know, Nathaniel didn't mention it, but the TAPR is having a forum, which will be Paul Elliott and myself talking about changes to TAPR. And then Nathaniel, you guys have a HamSCI forum. I don't.
Yes, that's right. It's the afternoon, Saturday afternoon at 4 p.m.
Yes, ours is Friday at 9. So right
and early.
Bright and early. And we're in that.
So we're kind of bookends. You know, first thing on Friday, last thing on Saturday.
Yes, and somehow the TAPR forum got moved out to the 4-H room, which is room number 4, which is over by the stadium. It's an old building, and so that's where we'll be if you are looking for us. Okay, next on the list is Jonathan, KC3EY. Go ahead, Jonathan.
Hi, everybody. It's been a busy week, busy weekend in VLF Daisy 2 developments. So the thanks to Scott's ideas, I did some more troubleshooting about my issue with the pulse per second signal on the serial port on the thin client PC that I've been having problems with where it would not detect it. Well, it turns out that the issue was that the RS-232 converter board that I ordered many years ago, back in 2019, for this prototype GPS interface that I have. It wired some control signals together, and the signal or the channel that I needed was wired to the wrong place. Was wired to CTS, but it turns out that what I had to do was I had to take off the connector. I had to cut some traces, because I also checked with the other GPS interface that I used, a project called PPS Piggy, and that worked. That worked perfectly, and the PPS was fed into pin 1, carrier detect, and that was working perfectly. So once I modified that little adapter board that I had, then everything started working perfectly. So there's no problems or issues, and it is working as described, or as it should, which is a big weight off my shoulders, because that was one of the things that I just could not get working. So that means that's very exciting news for the GPS interface. Paul, I do apologize. I don't know if Paul is on, but I meant to email Paul with some more information. What we're going to do is we're going to we added a jumper to give the user an option for a pulse stretched pulse per second signal, kind of like John Ackerman's fat PPS. And we're also going to add a jumper to route the PPS signal either to carrier detect or CTS, because that's also the other option. And that should be it, and that should make it very compatible with a lot of serial ports. So I was very, very happy about the development of this, and it's nice that I'm going to have an actual GPS interface to function as it should, to work as it should, to complement the Daisy 2 VLF system. That's all I have. Back to the next.
Very good. Next on the list is Jay Schwartz, WB8 SBI. Sorry.
Yeah, I'm just joining the crowd here. Looking forward to this weekend and making the pilgrimage. Thursday, I'll be at Contest University, and then Rise and Shine at Dark 100 at the fairgrounds. Changing the subject slightly. Hey, Dave, N1HAC, I got your message. I'll have the equipment with me in the car. Dave, are you going to be at the Tapper banquet? Are you going to that?
Yes, I am.
Okay, I'll have it in the car. That
That'd
seems
be
like a
fine.
good place to transfer it to you.
Okay, thank you.
Yeah, it turns out the where I have the VLF station in my house, it just isn't a good location. So, and
Right.
there's no other place to put it on my property or in the house. So,
Yep.
I'm going to turn it back in. Oh, bummer. Well, at least we got some data, I hope.
Yeah, well, George Burkett has said he'd host it.
Yeah.
He's over
Okay.
near Ann Arbor.
Yep.
Yeah. So, okay.
Thank you.
Hopefully he has a better location than I do. And, more access to the outside.
Right.
Anyway, just looking forward to the pilgrimage this weekend. So with that, back to Net.
Okay. Next on the list is Mark in a 6VI, and Mark is usually, he's got Mike muted. So I don't know if he's back in Asia or not, but welcome, Mark. And then we have Dave, KD0 EAG. Go ahead, Dave.
Not much to tell today. I've had a bad toothache all day, and it's been distracting. So that's really all I have to say. Take care, and I'm going to back out right now.
Okay. And then we have Clint K7OEI. Go ahead, Clint.
Just listening for the time being. I'll have more later.
Yep. And that's it for the list tonight. I know that Phil was traveling this week, I think. He said the ARDC was having a meeting before Dayton, if I remember right. So we're open for general discussion.
Don't everybody talk at once.
I feel like there's a lot to talk about, but I've just I think there's just so much on my mind. I'm just like, I don't know, done for the day.
Well, that's tradition here on the webinar just before Hamvention, that other than saying who's going there, no one really has anything new they want to talk about other than I'll see you at Hamvention.
Yep.
I did. So one thing is, on David McGaw's, I think, recommendation, he did notice a few RX 888s that were available on Amazon last week that looked like they were available quickly. And we thought maybe they won't be hit by the tariffs. So we tried to order them, and it looks like the order might be going through. So so far it hasn't been canceled, and we haven't been told there's been large amounts of money to be added. So hopefully right after Hamvention, I'll have at least 12 RX 888s in hand. I still want to keep going. I still would love to see like an actual tapper version of this thing.
Yep.
So I don't want people to stop doing what they're doing. But I will be very happy to have at least 12 in hand, and then we can keep going with that.
Yeah, let's hope. One thing that has been noticed is that some of the pictures don't say RX-888 on them.
Mm-hmm.
But if they work, and if we have them, great. And if not, Amazon's good at refunds.
Yeah.
Also, the tariffs have been reduced, not to zero, but been reduced to 30% now. So
yeah, it's a much friendlier number. So I think it's still very interesting.
I know Tom's been working on. Actually, he's been working on the 4-channel, correct?
I think.
Oh, did he drop off? Oh no, he's still.
No, he's here.
Yeah, still working on the 4-channel.
Oh, you muted yourself.
All right. Yeah, still working on it. I appreciate your input on the front end, and I ripped out the old parts and put the new parts in.
Yeah, Tom was trying to put a different part in with perhaps better noise, but it turned out, one, it isn't any better than the VGA that is currently used in RX-888, and it's also on end of life. So that doesn't work out. So I recommended we just keep the one that we have if we can find one with lower noise. But the fact is, looking at its specs, it's actually quite good. And rated as nanovolts per root hertz, it's 1.9. And you don't get much better than that with a general amplifier.
Yeah, I did measure that front end and got about 8 dB noise figure.
Yeah.
Most of it was due to a couple dB of loss of transformers and filters and things in front of it.
Yeah, so with careful design, low loss in front of it, it's probably fine.
Yeah, if we have an application that really needs lower noise figure than that, we'll have to put an external preamp in front.
And I think that's the right way to do it because different antennas will want different types of preamps.
Yeah.
An E-field antenna uses a different preamp than a loop and such, and a dipole. And the other part of it, you notice that it's probably no point to putting the attenuator in front of it, which is just another level of loss, and we don't really use it.
Right. I think Phil said as much. He never saw any value in turning on that attenuator.
Yeah, in fact, I believe the VGA has attenuation settings. It's not just its lowest gain is not straight through. There actually is some attenuation available in it.
Yeah, of course, as you reduce its gain, its noise figure goes up as well.
Right, as it will.
Yeah.
Because you need a certain amount of gain ahead of the A to D just to control the A to D's, override the A to D's noise figure.
Right. I was going to use capacitor. I have to AC couple the VGA into the ADC. And so I'm designing a network that'll give pretty good low frequency roll off and still rolled off a bit at the high end. That VGA rolls off about 110 megahertz, I think.
Right. And it's all prototype anyway. We can always change it.
Well, that's true. It's just parts and surface mount. I've noticed on DigiKey, some of the parts say not available for order until tariffs get resolved.
Yeah, well, so be it.
Yeah. Yeah, Scott, I'm signed up for that Infineon seminar tomorrow morning. Appreciate the note. I don't know if it's going to be live. They're running it tonight or tomorrow, Europe time, and then they're rerunning it for US time tomorrow. And I don't know if they'll do a live session again or if they'll just play a recording of the first one. Franco has figured out how to make a couple of the Infineon libraries are not yet updated for the FX10. And Franco found a workaround for one set of the drivers, and he posted that. And it's good. The state machine software is not yet available.
Where's the link to the webinar available for the FX10?
You've got to sign up ahead of time, but let me put it in the chat.
Okay. What time is it?
It's 9 a.m. Pacific time.
Oh, noon our time. Oh dear. Yeah. Oh well.
Yeah, there's another one. If you enjoy some 2 in the morning, I think you can get in on it.
Oh, okay. Yeah, the other thing, if you sign up for it, they'll send a link for the video afterwards.
Yeah, probably so. Most
They
places
usually do that.
Yeah. Hey,
That's
let me
I
find
often sign up with that intent.
Yeah.
Yeah, I have another meeting at noon our time.
Okay. The email I got says I'm ready to go and a button to join, but not a link for where it is. I'm going to have to do a little more searching.
Elmer, now that you're back, I was going to email you. So I was working on the VLF loop preamp schematic, and I got that all done. And I was wondering or if you would be interested in taking a look at it and playing around with it and possibly building and testing it.
Absolutely.
Okay. So first, thank you, of course. Secondly, so this loop preamp It's going to use something like Romex wire as the actual loop, like a 3-turn loop, and it's going to use Romex wire.
What you do? Put it inside a PEX pipe or something?
So Paul Nicholson, when he installed it, he kind of hung it on masts.
Oh, okay.
And Morris, Dr. Cohen, who installs his awesome DLF loop receivers in different locations, he also uses a mast to hang the loops. So this is going to be two channel. The only thing is that the original design, which is from Paul Nicholson, the original design, it includes a line driver, the LT1010 line driver, but before that there's a TL TL082 or 81 gain stage, and but I think that mainly does filtering. But I omitted that in this design, and I'm just using the filter that was in the E-Field preamp that you built. So like after so the filter network that's after, or the RLC that the main front end op amp is connected to. I took everything from that RLC all the way back to the audio isolation transformer, and I added that to this circuit, the loop preamp circuit. So it doesn't have the TL081 stage. I don't know how it's going to work, but it would be, but that's how I originally had this design in mind, and I was going to actually build it. I have all the parts to build the preamp. So I will send you an email, and I will get all that information to you. Did you make any more, or did you figure anything out with the current noise situation?
No, what I did was this morning, I built this. And what again, I'm just playing around with ideas because I have other uses for this as well. But I built a 60 hertz notch filter, and I wanted to see what would happen if I just applied this between my antenna and my sound system. If I just got rid of the horrible 60 hertz that I have here, what that might do.
Okay. There was an article. So if you search Google, Charles Wenzel, he and his design, I believe it's called the peanut butter can Whistler receiver. So in that design, he adds a 60 hertz notch filter on the input of his antenna. And what he did was he designed that filter specifically to match the high impedance. So if so there might be some loading depending on your filter is made, but there might be some loading, and it might like pull down some of that.
Yeah, I was worried about that, and I've been researching how to avoid that. But if I were just to use this as, yeah, yeah, it's the high impedance input that concerns me because I don't want it to detune it.
Right. Yeah.
Yeah, well, you probably want to bring the signal in and then filter the 60 hertz out.
Yep. Well, that's the
one thing
edge test.
you might do a search for is what we call PLG filter, power line garbage. And I know our engineer emeritus had designed them using switch capacitor techniques, and they can be very tight around 60 hertz and its harmonics.
Okay.
Yeah, and the peanut butter can whisper receiver might be of a similar design, but it's basically think it's I forget what kind of network it is, but it's but it's definitely something you can look at. I'm not sure how well it'll work because, well, so obviously there's the 60 hertz fundamental, which the preamp already has, or has a filter which kind of rolls that off. It rolls off the fundamental. And when you set up VT SID to monitor mains hum, I don't know if you have that set up in the configuration file.
Yep.
Okay.
Yeah, without it, I would have nothing.
Yeah. Because what you would because what I see is usually the 60 hertz fundamental on mine is a little lower in amplitude because of that filter, and actually 180 hertz is much higher. So but one of the main problems is not just a fundamental, but the harmonics. That's the killer, because especially in those environments with a lot of power line hum, it's the harmonics that are actually the major problem. You can notch out 60 hertz, but it's going to be hard to notch out the harmonics, and usually that's the major problem. And you can tell when you're listening to it. Obviously, if there's a lot of bass, that's the 60 hertz. But if you notice those high frequency notes in there, that's all the harmonics.
But Jonathan, this is what I'm talking about. The PLG filter is a switch capacitor filter, filters all those harmonics as well.
How does it work?
It is basically switching a capacitor bank at appropriate frequency. And it has a very sharp notch at the 60 hertz and harmonics, but then it passes everything else through. So it's a comb filter.
Okay. Is it a software, or where is?
No, it actually, well, you can do it software, but the one I'm talking about is actually an analog filter.
So I put a harmonic filter on a 8-pin pick for optical communication purposes, and the easiest way to do it is with an IIR type filter, and although FIR filter works just as well if you want to go through the trouble. But essentially what you do is you delay the period of the line frequency and feed back that in inverse, and then magically everything else goes away, all the harmonics go away. The old way it was done with those old-fashioned bucket brigade devices that used to exist. But you can still, I mean, if you wanted to mess with it, you should be able to get one of the, and just interested in audio. There's a chip called a let me see if I can find it, a PT-2039 or something. It's used for reverb in guitar. Is that the right number? You're nodding your head, Elmer.
I remember using it. I don't remember the part number, but I had had those.
Yeah, and in theory you could clock those precisely, and those actually have about 14 to 16 bits of effective resolution, and you can get the dev or the board off Amazon for, 10, 15 bucks, and people have used that sort of thing in the Whistler world to quash the harmonics, because the main thing you need to be able to do is have a delay period equal to the period of your line frequency. And if you're powering it from the line, assuming you have a stable reference of your own line, you can use it to self-clock, which is one of the nice things you could do, because you know what the frequency already is, because it's probably powering whatever it is you're using to listen to it with. But anyway, if I can find the device, I'm just looking here in a reference. PT-2399 or something 2399. It's a music refurb effects board, and those I have seen articles where people use those for exactly this purpose, and I couldn't point one off the top of my head, but I have.
They're a whopping $2.20 each.
Oh no, they've gone down. Yeah, I ran across this board when needed a delay board and a repeater controller, and the original board was an insane price. So it's like, wait a minute, these do much better than the original ones. So anyway, so and you can make them as narrow as you wish. I mean, you can have them millihertz narrow, but the problem is, I've discovered, and it probably is not a problem at the really low harmonics, but the upper harmonics, like in the hundreds of hertz, you get spectral spreading due to angle modulation and unstable triggering, such as from motor speed controllers and rectifier firing, which is annoying, or triac controls.
Yeah, I hear a lot of that stuff here.
Yeah, they just wobble. So everything, it goes from being a nice narrow line, the low harmonics, to getting fatter and fatter the way farther and farther you go upwards. Frequency.
Well, I'm not going to solve everything. I just want to beat the horse down a little bit.
Yeah, that's really interesting. And the techniques that you were describing, that's how Paul Nicholson designed his mains hum tracking filter, it sounds like it's a very similar technique. So that's actually pretty interesting, because there would be some nice development, at least with the portable VLF receiver, that it could do some filtering without having to run it through software. But yeah, this was a really good really good talk about that, because I that's one of the techniques, or one of the main issues is all the mains harmonics, and that's an interesting technique. So I mean, maybe I think ideally in the future, maybe we'll kind of roll our own super fancy VLF receiver, which incorporates both analog and digital techniques in the preamp, um, filtering both in hardware and software. So, um, there's a lot of potential for this.
Yeah, I'll see if I can scare up one of the designs for this. I know we've, as I say, our engineer emeritus has done this more than once. I think I can scare up one of his designs.
Mr. Trimpy?
Exactly.
Ah, yes. Yes, thanks. Thank you. Yeah, that'll be really interesting too. Clint, while we're on a similar subject, I sent an email 2 weeks ago with my schematic for the interface for the VLF receiver. And I was kind of curious as to your opinion on those decoupling capacitors that I added, and I grounded them to the ground that I'm actually looking to isolate from. So I was just kind of curious about your opinion, if you had a chance to look at that.
Okay. My question of did you send it to me implies that it's 2 weeks ago I was not in town, so I'm drawing a blank on the email to which you're referring, so I'll see if I can find something.
And it might have been, perhaps I sent it to the wrong email.
If you give me a word or two in the subject line, it help me see if I can find it.
Okay.
But there's like 4 email addresses that you might have sent it to.
Oh.
And I should get them all of them, but sometimes, depending on what one you send it to, sometimes attachments get thrown into emails with attachments get unceremoniously thrown into spam bucket. Depending on, I mean, it's not as bad as having a Comcast email address, but it's almost as bad on one of mine. So
yeah, I have a similar issue here. Let's see. It was actually here.
One of the things I was talking to Glenn Elmore about last week was the use of active current sources to isolate ground, isolate power. And I guess you could even use it for signal lines if you really wanted to, but especially useful for isolating power connections. And if you're not familiar with the current source, any device that functions as a pure current source has infinite series, has infinitely high impedance. Now, there's no such thing as a pure current source, and that would also imply an infinitely high compliance voltage. But you can get into the many K ohms with just very simple circuits. And I bounced it off him if
that ought to work. And he said, don't know why not, but I've never seen anyone use one or VLF stuff to isolate their power. In theory, you should be able to get many kilo ohms of effective impedance on a DC line to power your device through at least tens of or hundreds of kilohertz with just a handful of transistors and passive components. And then above that frequency, you could just throw in conventional LC circuits to augment it, just as long as you're careful not to make an oscillator.
Right.
But I have not done it myself because before I went through not for VLF stuff. I've done it for optical detection. Project I was involved in a long time ago, and it worked perfectly there in a sort of vaguely similar way. But the downside of it is that it could be extremely sensitive to lightning unless appropriate precautions are taken, because essentially what you're doing is hanging semiconductor junctions out in the breeze on the ground. That should be fixable, or it should be protectable, just as any other receiver or active device can be protected. But it's one thing to which since this has apparently never been done that I've run across, it'd be worth trying. But it's just on my very long to-do list.
Yeah, that sounds really interesting. Because if like do you think that it could be something that could be used where we could cite both VLF and an HF antenna, and the isolation, the power isolation, it could be filtered with LC networks and for the higher frequencies, and possibly won't cause too much interference.
In theory, that'd be true. I mean, you could make one of these with just an LM317 and a single resistor if you were so inclined. I mean, it does have several gotchas. I mean, you'll be wasting a lot of power. If you want just a couple watts, it's probably fine. If you want tens of watts, you're just asking for it. I mean, I presume that one of the goals in this would be to, at the lowest possible power level, boost the signal and get it across whatever the conveyance to the receiver station would be, whether that be balanced line or fiber optic or something. So anyway, one of the things that I was kind of looking at for the Utah SDR is we have lots of acreage, but we can't run wires because we have cattle.
Yeah.
There randomly, because that's what the landowner does. And I was thinking of something solar powered with a wideband FM transmitter conveying the baseband, VLF across, and then simply using something like K9Q radio to recover the baseband, because it could be done trivial or something like that. I don't know if that would have the appropriate dynamic rate, but that could be something that would be trivial to power entirely solar, that would only do tens of milliamps, and also be completely and utterly wireless. But and we have plenty of fence posts to put it on, but that's just one of those things that's also on the list to do. I mean, there's a bunch of ways to skin a cat. So
yeah.
But to answer your question, I think it could be. It's just that one of those things I haven't tried yet in this particular instance. But I'd imagine to put it this way, if you're going down below a few hundred hertz, unless you have access to some really exotic magnetics, like swinging chokes that happen to be low capacitance or something like that, you're not going to be able to isolate it any other way.
Right. Right.
If you're intending on conveying DC. If you're doing AC, then that's also a solvable problem. But if you're doing DC, this is the only way to go. The only way I can conceive of the work.
Yeah, I also agree with you. There was the author of Spectrum Lab. So he did something kind of similar, and he made up this transformer with the two loops of or two toruses of ferrite in like as a chain link actually, and he was able to it's on VLF.net. His design, and I believe that he did use some exotic.
You must mean Spectran, not Spectrum Lab, because that's I think. Yeah, I just looked it up. You mean Spectran, I think. The Spectrum Lab is the German one.
Yeah, that's
Spectran and Argo are Mr. DeBene and the other one. Yeah, I know who you mean.
Yeah, yeah. Or no. I'm actually talking about Wolfgang.
Oh, you are okay. You are.
Yes. Mm-hmm.
Okay. I gotcha.
Oh, but anyway, to get back on the other subject, the subject line for the email is rearranging equipment.
Oh, okay. I did see that. It looked like somehow I thought it was somehow when I read it, somehow I thought it was an exchange between you and Glenn that I happened to be included upon, but I'll reread it more closely.
Okay, it just I just let me know what you think, because I was kind of unsure myself, and when I was doing some testing on the I built a interface box, like a test box, and I remember because I made it both battery powered and powered from a wall adapter, and I noticed when I plugged it in, there was a slight increase in background hum versus on battery, and I was kind of wondering if that was one of the ingress through those decoupling caps. However, that's the design that Paul Nicholson used on his ILDN receivers. Now, ILDN is the Indian Lightning Detection Network. ILDN.in is a website. It's a lightning detection network run by a bunch of universities, about 10 universities collaborating, and he designed the VLF systems, and that was one of the design, or that was what he used on the back end processor, which included the VLF interface, which isolated both the signal and the power using those DC to DC converters. But from what it looked like, the decoupling caps on the output of DC to DC converter that feeds the loop going to the preamp, those were grounded to the ground that he was trying to isolate from. But Elmer did some testing, and I remember he said that that 0.1 mic was seemed to be the optimum value. But yeah. When you get the when you look it over, I tried to provide as much information as I could, and I do apologize if it's wordy, but yeah, because I do want to build, or I do want to spin some boards, but I don't want to I don't want to. I'd like to try to finalize the design as the best I could, and that was kind of one of the questions that I had. I figured I would ask you before I actually spin out a board for it.
Okay, I'll look over it. I'm looking at it now, and I'll have to, I have to put my head into it to follow it.
Okay, that's fine. Yeah, and I do apologize if it's wordy.
Well, I mean, I'm not familiar with the modules that you're using, so I'm gonna have to reverse engineer it to understand what's going on. It fully, I guess they are isolated, but yeah.
Oh,
yes. Yeah.
Yes, the IP 1215S, those are from XP Power, and yes, they are isolated.
Right. Okay. Yeah. Okay.
And there isn't much spec on the isolation. I think there's just one parameter mentioned on the data sheet, but
I mean, one thing that is useful to do on isolated DC to DC converters is to measure the capacitance across the input and output when they are powered down. Because, for example, if they're intended for EMC compliance, they'll often have like a class Y capacitor of 1,000 puff or something between the input and output. But then again, if they're point of load, they may not have that at all. And that would, and also, and if they don't have that at all, then the winding capacitance between the two ends, maybe, or plus opto or whatever they use for the feedback, maybe on the order of only a few tens or 100, maybe 100 picofarads. And that would, what the scheme was done may dictate how much grunge gets sent down the lines by them. But if you're placing something like this at an antenna, it doesn't matter how much they have filtered it, it'll always be too much.
Yeah.
I mean, it's just the way it's going to be. I mean, one of the things that's also useful to do that when I'm noise proofing stuff is connect a receiver or a spectrum analyzer directly to the power supply terminal via a blocking capacitor to see how much stuff is coming out and at what frequency. And that is also very useful to do because if you can't hear it when you connect your receiver directly to the thing that you're thinking is making the noise, then it's probably not that thing that you think is making the noise is where the noise is coming from. And you probably filtered it well enough. If you do get a lot of racket, then it's possible it is, but there's been a few instances when I've had these switching supplies that the choice that I had, that I chose, the choice that I made was to make it so quiet you couldn't really hear anything hardly at all when you connected your HF rig right to the power supply. Then I knew it wasn't the device, the power supply, that was the cause of the racket that I was chasing down. I mean, you have to pick your battles and know your enemy and every other cliche you can think of before you start seeking out these noise sources. But anyway, you're looks like you're kind of in the right direction. Although this on this schematic in this email, I guess. I mean, so is this device you sent in the schematic the thing that is at the shack, or is this the thing that is at the antenna?
This is the thing that is at the shack. This is the
okay.
What's going to be the VLF shack board, I guess.
Okay, I see. Other than it looks like you've coupled the noisy ground of your shack right onto your E-field terminals. I mean that's the ideal situation.
Right. For the
I see these point ones to the ground, and would that be you connected however noisy your shack ground is to the remote ground out yonder? And, but then again, you know, as you pointed out, decoupling DC is an SOB.
Yeah.
So, but anyway.
I mean, well, there's always like some, I don't know, maybe I could use some other, I don't know, like a floating ground. I'm not really sure. I don't know how to, like.
I mean, when you were talking about the thing earlier on the VLF.IP side, but the first thing that came to mind were the ring transformers that they used to power tower lights on AM broadcast stations.
Right. Nathaniel and I just saw one in person 2 weeks ago. Yeah, it was a ring transformer, and
now those are gross overkill. But if you want to find a transformer that is close-ish to that is readily available, a lot of the split bobbin power transformers, if you're talking about good old-fashioned iron, split bobbin power transformers have relatively low coupling capacity because you can tell by the way it is that the primary and secondary are next to each other and have relatively low coupling area rather than wound top each other. Now those aren't perfect, but the split bobbin one is generally quieter in broad sense than the overwound common type.
Mm-hmm.
You know, because they have much better longitudinal isolation, you know, in minuscule currents than, you know. So I don't know. But anyway. The other thing that came to mind in this discussion too is that if you did have a switching supply, you could pick a frequency you don't care about, like 100 kilohertz. I mean, out here in the West, 100 kilohertz, Loran is blasting away, so you're not going to listen to that anyway. So if you put switching supply, if you put say a well filtered sine wave at 100 kilohertz down the line, and then rectified and filtered at the far end, you could probably, by the time you got to HF, you could probably make the harmonics go away, and the 100 kilohertz would be entirely above your VLF frequencies of interest in the first place.
Right.
And then for that, you could use a standard audio transformer. I mean, they're kind of lossy when you get up to 100 kilohertz, but they're not I mean, you lose 20-30%, and so what, or something like that.
Yeah.
But I mean, there's a whole lot of ways you can do this. I mean, enough that I haven't tried them all, but anyway. But I do understand that one of the goals is to make this easily replicated. So DFA, design for assembly, is the greatest challenge here. Finding something that using off-the-shelf parts that would be cheap and easy to replicate.
Yeah. Yep. Yeah, that's especially when we get into these exotic magnetics or something like that. It can be
right.
Um,
Which is why, you know, lowest frequency like 100 kilohertz, you could get away with a pulse transformer from Mauser key or just an audio transformer or something.
mm-hmm.
I mean, yeah, even yeah, even Ethernet magnetics might work. I don't know how low they go. I haven't measured measured them recently, but those things are pretty common anyway. Yeah, ISDN iron.
Mm-hmm.
Anybody
Yep.
has ISDN anymore? I mean, like a phone transformer, a what
Yeah.
transformer? You know,
Yeah, even those um, uh, the kind of transformers that you would see on modems. Although I've noticed well, obviously 56K modems, their transformers seem to be higher bandwidth, but
well,
it
kind
have to
of.
be.
I've used them for audio, and they're terrible below about 300 hertz, and
Yeah,
and
yeah.
they're probably and they get and their curves get wobbly when you get above about 8 or so kilohertz. I mean, if you piped audio through them playing music, aside from the lack of bass, probably nobody would know.
No.
But they are meant to be cheap, and on being phone, there's no point in having it go below 200 or 300 hertz anyway.
Mm-hmm.
Their only saving grace is that some of them can handle hook current, but
Yes.
most of them can't. But some of them can anyway.
Yeah.
But yeah, it's one of those things. All right. Well, I think we probably bored a lot of people for the time being. I didn't mean to dominate things.
Yeah, my apologize. I didn't mean to steal away the conversation, but I just wanted to ask that question quick.
Right.
I think it was a good discussion. I do think though I'm probably gonna head out for the night, and I will see people in Dayton. And I think hopefully after Dayton, or through Dayton, maybe Elmer, I'll get in touch with you and with Rob and with Michael Howen, and we'll figure out if we have you come out here again in the near future. We'll try to figure all that out.
Awesome.
Great. Thank you, everyone. I will see you soon. Do you want me to leave this on for people?
Yeah.
Great. Jonathan, I will leave